Hello, hello engineers. May audible? I hope may audible. So till now we cover three classes on RC. So two class we cover that RC concept where we discuss the basic question where we have an input response is unit step and you are trying to determine what is the output when you have R and C. And in the first question you check it, okay, how capacitor is charging with that, okay, that what is the way that capacitor is charged. And the second question we say that input voltage is constant and it is drop after some time or suddenly it is dropping. So how capacitor is discharging? And after that we make a one pulse and we discuss okay, as per the time will be the pulse duration is decreases, so it will not fully charge, or you can limit that discharging also. So charging and discharging depends on time constant of the circuit and also the pulse width of the circuit of the input response. Okay, so if you are solving a RC circuit and whenever you are going for an analog circuit, you will find that RC. Because I am just placing R and C, you can think in this way you have a metal and metal fringe. Okay, if I am using a current source, you can think in a way that is a current mirror in an analog circuit. So if you know this current mirror and current and that is amplifier, so you can relate these concept in your circuit design. So till now we discussed the voltage source. Now I am going for a current source. Okay, that current source is a constant current source. What will affect on the capacitor side? So the first question we have, so we have a first question where we have a current source and you can think it is a current source or you take as a current mirror. Okay, so this is a current source. The constant current is passing through a circuit that R and C are in series, but the condition is before T1 that it is a switch. Before T1 the switch is connected, after T1 the switch is open. So just break this problem in a two way, and in this circuit we are trying to determine what is VR and what is VC, the resistance voltage, that this node voltage and this node voltage with respect of reference node, that is ground. So I am just thinking in a way ki before T1 what is happening. Before T1 means that before switch is open, but the switch is closed before T1, and after T1 that will be switch is open. So I'm just thinking of okay, that before T1 what the circuit is like this, you have a 5 volt, you have a current source that is I, and you have voltage is 5 volt, and you have a resistor, and this switch is connected. So this switch, let this is a capacitor is present, but this switch is connected like this before T1. So this is a parallel and that is the short circuit path. So current will not enter at this node. The current is 0 here. And you can say that capacitor voltage will be 0 because they are a short circuit. And if you are looking this point, what is the VR? So before T1 that current is entering to a resistance, and this current is I here, and after this it is entering here and it is will follow like this. The capacitor, through the capacitor there is no current because in parallel the switch is closed, so this is a short circuit. And what is VR? So VR is equal to I into R, and this the voltage across capacitor is 0 because this is a parallel, that is 0. So I can say that before T1 the voltage is IR. Okay, so voltage is IR. I can be any value, R can be any value. Okay, so if you know that ideal current source can take any voltage across it, that I and R will decide what will be the potential at this point, at this node, because I into R. There is no meaning of 5 volt because this is a current source. Here it is a current source. It will not limit by the 5 volt. It will be the defined by the current source, because in a series that current will be dominate as compared to voltage source, and a parallel voltage will dominate. So before T1 that I can just break this problem. So before T1 I can say that that VR is I into R, and what is VC? So VC is 0 volt. So I can say that the voltage across capacitor before T1 it is 0, and before T1 that VR is equal to I into R. Okay. So if you are interested for the waveform, so I can represent in a way, then let this is time is T1. So before T1 the voltage is I into R. VR is I into R, and if you talk about VC is 0 before T1. So before T1 that voltage across resistance is I into R, and before T1 that capacitor voltage is I, that is 0 only, because there is no current through a capacitor. Just after T1 what is happening? After T1, so, or you can say that T1 plus, that capacitor is here. This is your VC and this is your VR, and now this switch is opened here. After T1 the switch will open, so this current I will pass through resistance also and capacitor also. And if current is finite, as we know that capacitor is, that current is finite, so I can say that VC T1 plus is equal to VC T1 minus. Capacitor does not allow sudden change if and only if that current through a capacitor is finite. As we know that current is finite through a capacitor, so before T1 it is 0, so it is maintained T1 plus also. So at T1 plus also it will maintain at 0 only. And that the voltage is what? VR is what? VR, I can say that VR is basically I into R plus VC. That is simply a series, that I into R plus VC. Voltage through a resistor plus voltage through a capacitor. Voltage across resistor plus voltage across capacitor will be the VR node voltage. So at T1 plus you have a voltage is IR only. And what will happen? The current is always I, so that the voltage across I, that R is always I into R, that is constant. But if you talk about capacitor, so what about the capacitor? So whenever you have a current and current is entering to a capacitor, so it will be what? That is I is equal to C dV by dt, dear. Let this is VC, so I am writing VC here. And what is dVC by dt? dVC by dt is equal to I by C. I can say that capacitor will charge with the constant, that dVC by dt is I by C value. The slope is constant. Voltage with respect of time, because you are designing a graph in terms of V out versus time. So this is a constant voltage. And what is that value? That VC is equal to I by C integration of dt. Is a constant slope with that. It is behave like a ramp function. Okay. So if you are interested to make the graph here, so as per before T1 it is 0, and at T1 plus also it is 0. But after T1, that as per T1 plus to some tending to infinite, as per the time will increases, that this will be multiplied with I by C. The slope is I by C, that is constant slope, and it is increases like a ramp function there. Just like a dy is equal to mx plus c, that m is I by C. The slope is I by C is constant there. with respect of time as per that I by C into T. Okay, so that will be your capacitor voltage. Whenever you have a constant current and the constant current is passing through a capacitor, always capacitor will charge ramp in a function, it is showing that in a way like a ramp function. Okay, so if you are thinking like this, what will happen? So after T1, this value will be increases with the slope of I by C, and that is very important point here. Once you go for the current mirror and you will use this funda, you will use this in a, that is integrator. Once you use a op amp, okay, they are very important for converting from what that is square to triangular wave generator. Okay, so you can use, or you can use a passive component also, as here you have a passive element, not a op amp, that is op amp is an active element. You have a passive element. By this also you can generate a triangular waveform by the help of square wave. If the current is square, so it will be like this. Okay, and what will be your VR? VR is IR plus VC. VC is increases like this, so VR is also increases like this, because VR is IR plus VC. VC is increases in this way, so VR will be increases like this. So this is the funda we are talking about it, and that is very important question. Okay, so once you go for the interview, they will try to ask in a way, okay, you have a current source, you have a resistor, and you have a capacitor. What is the resistance? What is the voltage at that node, and what is the voltage at C? And if you are thinking in a way, whenever you have a current is entering to a capacitor, it is always from a one constant slope, that is I by C integration of dt. So voltage will go in a ramp function. Okay, if you are interested to make that waveform in a way, that just convert this waveform, let this is I is constant, make that current like this. Okay, and just check it, what will happen. Okay, what will be the output? You can. So you can check it in a way. So this is the way you can try that. Okay, and this is very important once you go for that op amp and you are going for a current mirror. And we are also use this in a charge pump. Okay, when we are talking about charge pump now, we use this circuit and RC with a constant currents. Okay, or we can limit that voltage. Okay, we can limit the voltage. Okay, you have a capacitor, and in parallel we can define in a such a way okay, that VC will be constant. Here that VC is increases as per the I is increases. We can control that capacitor will be constant, that C will be constant. How can we can use a Zener diode here. If you want, we can use a Zener diode if you are interested to understand. Okay, that is your VZ. So as you know that the Zener diode is what? Basically in Zener diode, whenever you that this capacitor voltage is not near about or less than VZ, that Zener diode is behave like a open circuit. It is a reverse bias. And once VC will be equal to VZ, that VZ become a constant supply and VC will limit. Okay, so we have a lot of way. Okay, but firstly understand, we will only use RC diode, Zener diode, okay, voltage source, current source. These are the basic elements only, and MOSFET, of course, MOSFET. By this only you can generate your own design as per the requirement. I want, okay, just I am thinking in a way, okay, I want that that capacitor would be constant, and after this point, after this value, it will be constant. Let I am thinking in a way, okay, this will be your Vz. I want that it will be a constant. You can use a Zener diode voltage. So capacitor will charge with the I by C slope, and Vc is increases ramp function. And after some time, once that Vc will reaches to Vz, this Zener diode will be break out and it will provide a constant voltage. After Vz, it will not charge. Yes, it will be behave like a constant supply. That Vz will behave a constant supply, and that remaining current will pass only this point. So you can limit also. Yeah. I am giving just idea ki how the charge pump is working. We can limit this voltage also. That capacitor is going on, but I can stop it. Just use that Zener diode or MOSFET. Okay, we can use a MOSFET also. So we have a variety of elements to limit that. Okay, that stop at after that point. Okay, so this is the way. Yes. Go for the next question. Okay, the second question we have a V input, we have a R1, we have a R2, we have a C. Now you have a constant current. The input voltage before T1 it is 0. After T1 it become a 10 volt. Just try at your end here. Okay, these are the question where you can analyze. You have a basic understanding of RC or not. So I am just thinking in a way कि okay, the input voltage is 0 before T1. So I am converting this input is a short circuit with a ground, and find that what is the initial voltage across the capacitor, because that capacitor before T1 behave like an open circuit in a steady state. So I just break this circuit. I just break that circuit ki before T1 what is happening. So before T1 what is happening, that input voltage is 0 there. Input voltage is 0. You have a resistor here. You have a resistance here. You have a current here. And just I am saying that you have a capacitor here. And this capacitor is act like a open circuit. Why? Because in a steady state it will be act like open circuit. So why steady state? Before T1 it is 0 for a long period of time. For a DC state, before T1 it is looking like a DC state, and DC state will be that capacitor act like an open circuit, because I is equal to C dV by dt, where that dV by dt is 0. So that's why I am saying that I is 0, means this capacitor will be open. You have a R1 and you have a R2 and you have a current. You are talking about what is the V out before T1. I'm just use okay, that current is passing, the maximum current it will not here through a capacitor because this is open. So I can say this I will be pass here and pass here through R1 and R2. And if you know that network, you can write in a single line what is the voltage here. So what is V out? Basically the voltage across R1 or voltage across R2, that will be, because R1, R2 and I are in parallel. All are in parallel. R1, R2, C, all are in parallel. If you are looking this node, this is A node and this is B node. In between A to B, that R1, R2, current and capacitor, all are in parallel. So just determine it current through R1 or R2, just multiply with that impedance and you find that V out. So firstly, what is IR1? I can write it IR1 is equal to I into R2 upon R1 plus R2. This is the current through R1, current division. Okay, whenever you have a two impedance, you can use a shortcut method. Otherwise, you use I into 1 upon that impedance upon 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3. We discussed in a network class. Okay, so IR1 is IR2 into upon R1 plus R2. This is the IR1, the current. This is IR1 there. Okay, and if you talk about what is the voltage, so voltage is what? Voltage is V out is, that is IR1 into R1. So this is become I into R1 into R2 upon R1 plus R2. And that is very basic, that is network. There is nothing. Okay, if you good in network, you can solve in a single line. If you are not good in network, it will take time. Okay, so just I am thinking in a way कि before T1, the I into R1 R2 upon R1 plus R2, this will be the voltage. I am just generally thinking in a way कि okay, the before T1, oh sorry, before T1, this is the voltage, that is I R1 R2 upon R1 plus R2, and that will be voltage across capacitor also. And of course, please focus on the direction. The current is entering in a way, so this is a direction. So of course the capacitor across that, the sign is like this. Be focused on the sign, because sign is very important. So if you are thinking that current is entering and this current is positive, means that assumption is right, and this is plus and this is minus, so they are in parallel. So this is plus, this is plus, this is plus. So basically the capacitor voltage or V out or R1 voltage or R2 voltage or voltage across current, all are same because all are in parallel. So the voltage VC is I R1 upon R1 plus R2. So before T1, that VC is I R1 R2 upon R1 plus R2. And be remember what will be the direction. Direction right side on positive and the left side is negative. And we know that capacitor does not allow sudden change. So at T1 plus, what is happening? At T1 plus, the input become a suddenly change of 10 volt. As the input is changing, at T1 plus have a sudden change of 10 volt. The input is changing from 0 to 10 volt. So now the circuit will be like this, that this is 10 volt and this is your resistance, this is your capacitor here, this is R1, this is R2, this is C, and you are talking about what is V out, where that you have a current is I here also. Okay, you can use superposition theorem also here, but if I think I not cover that superposition theorem, so I am not going for the superposition theorem. I will solve in a basic KCL and KVL only. Okay, so that is the way. Okay, you after T1 plus, the input voltage is 10 and the capacitor voltage is plus and minus if and only if the current is finite. So I will check it, what is the current here. So as we know that VC T1 plus will remain at VC T1 minus if and only if the current through a capacitor is finite. This is my assumption, this is my response. Okay, so if you are putting this, so what will be the current? If that capacitor have a that value, you can define it that current is, if the capacitor voltage is here, or you can think in a way you have a resistance in the path, always current is finite. I am not going for proving, I am just looking of the circuit, just intuitively we are just looking of the circuit and saying that okay, you have a resistance here with the capacitor, with a series of that capacitor. So of course that current is finite. Okay, and capacitor will maintain that VC T1 plus is equal to VC T1 minus, and that capacitor voltage is at T1 plus, it will be I into R1 R2 upon R1 plus R2. It is remain same. And if you are interested for V out, so what is V out? This is 10 volt there. This is your V out. So plus direction on this side, negative is here. So V out minus 10. V out minus 10 is equal to VC. So V out minus 10 is equal to VC T1 plus. So at T1 plus V out become what? V out become as 10 plus I into R1 R2 upon R1 plus R2. Just focus it here that capacitor voltage is not changing. V out is changing. Why V out is changing? Because the input is increases by the 10 volt. It was 0 till T1. After T1 it have a same change of 10 volt. So your capacitor voltage is not changing. Your V out is increases with the VC plus V10. That VC is I R1 R2 upon R1 plus R2 plus 10 volt. So that V out is increases by the 10 volt. Just think in a way you are clamping your V out. That at the first position it is 10 R1 upon R1 plus R2. Of course that by the only of current only. That T1 plus it is I R1 upon R1 plus R2. As per the 10 volt is increasing, it is clamped to a plus 10. So if you are looking this circuit, I am just using that name, that clamp. You will find that whenever you are designing a IO circuit, or you are going for a charge pump, or you are going for op amp, okay, you will understand what will be happening. That interviewer is saying that clamp this voltage. So the clamp is what? You have a capacitor, you are adding some voltage. So V out become increases. So capacitor voltage remains same, but V out is increases to 10 volt. So I am saying that this will be voltage, that is 10 plus I R1 R2 upon R1 plus R2. These are very important point there. That is very simple, very small points, but these are the question where you face problem there. See, before T1 that voltage is I R1 upon R1 plus R2, but at T1 plus that capacitor voltage remains same, but V out is increases with the 10 volt, that a clamping of the 10 volt here, and this is the voltage. Yes, this is 10 I R1 upon R1 plus R2. So V out is increases by 10 plus I R1 upon R1 plus R2. And lastly, if this input is remains same, that the 10 volt is remains same. If this is going on, that is 10 volt is always same. What will happen? Just looking at the input is equal to 10 volt. It is remains same for t tending to infinite. So you have a circuit that you have a 10 volt. You have a resistor here. Now this you have a capacitor in a steady state, means t tending to infinite, means frequency is 0, capacitor act like a open circuit, or you can say that input voltage remain constant. This is a DC value. At the DC value in a steady state, capacitor act like an open circuit. So I am talking about what will be the final value of the V out, or what will be the value of that VC in a final state. So I am just focusing that this 10 volt is remains same. So I am just finding it what is the initial value, what is the final value, and we write that equation and we can find it. Okay, this will be the exponential graph. Okay, and this is the current, that is I is given, and what is your V out? Okay, so you can determine what is V out here. Okay, so that V out is what? Basically V out, you can use a basic what KVL here, KCL here. This is open, so that current is 0 here. This will be your V out. This is X, this is Y, this is Z. You can use X plus Y plus Z, that is basic KCL equation. I am not using anything, I am just using a basic network. and determine what is V out at t tending to infinite. So this is x is what, that is V out minus 10 upon R1, y is V out upon R2, and z is minus I, because this is up, this is a direction upward and z is downward, so this is minus I. If you take the LCM is R1 R2, so this is V out into R2 minus 10 into R2 plus V out into R1 is equal to I R1 R2. That is basic mathematics. I take the LCM of R1 R2, multiply with the R2, multiply with the R1, and multiply with the R1 R2. Okay, and what is V out? So V out is basically is I R1 R2 plus 10 R2 upon R1 plus R2. Just check it here. So this is I R1 R2 upon R1 plus R2 plus 10 R2 upon R1 plus R2. Okay, so at finally it will be reaches to that value. V out will be I R1 R2 upon R plus 10 R2 upon R1 plus R2. If anyone interested on the capacitor voltage, what is the capacitor voltage? You just define it, V out minus 10 will be your VC. The finally V out is what? I R1 R2 upon R1 plus 10 R2 upon R1 plus R2 minus 10, that will be your VC. And finally the capacitor voltage I R1 R2 plus 10 R2 upon R1 plus R2 minus 10. So if you are interested for determining what is VC, you can write it, that is VC is what? That is I R1 R2 upon R1 plus R2 plus 10 R2 upon R1 plus R2 minus 10. This is your, just define it, that is 10 R2 minus 10 R2 will be cancelled out. This is I R1 R2 upon R1 plus R2 minus 10 R1 upon R1 plus R2. That will be your value of VC. Okay. So if you write that basic equation of that, you can think like this, okay, the output is what? So after T1 plus, that capacitor voltage will be decreases exponentially and it will reaches to V out is 10 what? 10 R1 R2 what, that I into what, that value, that is 10 R2 upon R1 plus R2, 10 R2 upon R1 plus R2 plus I R1 R2 upon R1 plus R2. That will be your V out there. And you just write that equation V out final plus V out initial minus V out final e to power minus T minus T1 upon tau. Why T minus T1? Because after T1 the input is changing. So you are writing is V out final plus V out initial minus V out final e to power minus T minus T1 upon tau. Okay, that is the power of analog circuit. Okay. You are just clamping that your voltage to a 10 volt and it is decreasing but is not decreasing to 0. It will decrease but have a limitation. Okay. And of course I am writing in between this. Why? Because this is greater than I R1 upon R1 R2 upon R1 plus R2, that is 10 R2 upon R1 plus R2. So that's why I am decreasing in this time. I am not going below that. So any value you can put it. I is 5 milliampere R1 R2 and any value of 2K and 2K and just find it and you can. Okay, and you have a tool, you just check it, this is correct or not. But before checking, before simulation, please analyze in your way, okay, what is the output. Once you that analyze the circuit properly, then only go for simulation. If you are going directly for a simulation, that will be a problem. You can't understand the circuit. You always focus on the result. If you are a circuit designer, you must analyze at your end there firstly. Okay. So this is the way. That the circuit is just a basic that you have use a current source and you are using this circuit. And these are the general question you will face in your circuit designing. Okay. Let's talk about diode. The topic is diode with the RC. Okay. So we cover that current source. Now we are going for diode. What is the meaning of diode? Firstly, understand how the diode is working. So you have a diode here, you have a VA and you have a VB, and let this is V gamma, that is cut in voltage. So VA minus VB is greater than V gamma if VA minus VB greater than V gamma. So you can say that this diode is behave like a short circuit with the supply of V gamma. So it will be act like this. That will be a short circuit. If V gamma is 0, it will be a short circuit. If V gamma have some value, so it will be 0.7 or 0.3. If this is germanium, so this is 0.3 energy band. And this is 0.7 if you have a silica. Okay. And if VA minus VB is less than V gamma, you simply say that this is act like a open circuit. Diode is behave like a reverse bias. Okay, whenever you have a diode, you just check that what is that at P side, that is N side. Of course, this will be a P and this will be N. What will be the voltage at P side? What will be the voltage at N side? If P voltage at the P side or anode side have a higher voltage than cathode side, so you can determine in a way that diode can be a forward bias if VA minus VB greater than V gamma. Just determine what is the node voltage. If the node voltage follow this condition, you make that diode is a short circuit if this is ideal diode. If this is a practical diode, so this is a V gamma. And if VA minus VB is less than V gamma, it will be act like an open circuit, is a reverse bias there. Okay. Okay. So just understand this part and go for this. So you have an input voltage before T1. That input voltage is 0. So I am just designing in a way before T1 means T1 minus the input voltage is 0 and you have a resistance here and you have a diode, and I am not defining any V gamma, so always think that diode is ideal. Whenever you have a diode and that V gamma is not defined, just think in an ideal diode. So V gamma is 0 and I am using this resistance, that is this is R1 and this is R2. Okay, and you have a capacitor here. Okay, I am arranging that circuit like this. This is C and this is 5 volt. Okay, this is I am writing just convert in. This is a 5 volt, so 5 volt with respect of ground, and this is ground. So I am just convert here and make a simple one. Okay. So what is happening at the V out side? I am focusing on the V out. So if you have a DC value, for this, the capacitor act like an open circuit. This will be a positive because this is a positive charge and this will be a negative charge. So this have a 5 volt there. Because by this 5 volt there is no current. Why? Because this capacitor will block the DC voltage. So if you are talking about before T1, this is diode, this is our input voltage, this is your resistance, and this will be your open voltage. Just a minute. Is there any problem? What is happening that? Okay. Okay. So this is, oh, why this is happening there? Okay. So, okay, sorry, this is 5 volt here. So this is open, so there is no current. Okay, there is no any external supply. So if you are talking about Vout is 0. Why Vout is 0? This is plus minus 5 volt. This is minus, this is plus, that is Vout is 0. Capacitor is blocking. Capacitor will not allow to provide a 5 volt supply to the circuit. Capacitor will hold this 5 volt. And this will be a 5 volt across the capacitor, and I can say that what is Vout? Vout is 0, and capacitor have a voltage is 5 volt. And what is Vout? Minus 5 plus 5, it becomes 0, or you can say that capacitor will be act like an open circuit. There is no current here, so that the I into R or I into R there is 0, because after this, after 5 volt there is no any external supply. So you can think in a way, or you can think in a way, that is minus 5 plus 5 is 0. So Vout is 0 there. And Vout is 0. So before T1 minus, Vout is 0. And your VC is 5 volt, where the bottom side have a positive charge and the upper side is a negative charge. Now at T1 plus, the input voltage become a 10 volt. Now the circuit is like this. You have a 10 volt, you have a resistor, you have a resistance. Now you have a diode like this, and you have a capacitor here, and you have a 5 volt. What will happen here? Due to this capacitor, this have initial voltage that is 5 volt. Due to this is 0, because capacitor does not allow sudden change. So this is 0. Okay, the capacitor does not allow sudden change, so this will be 0. And you have a 10 volt here, and you have a 0 volt here. So this will be a short circuit or not? Yes, everyone. So that VA minus VB is greater than V gamma, where V gamma is 0. So 10 minus 0 is greater than 0. The diode is behave like a short circuit. And as per the input is 10 volt reaches, your diode will be short circuit, and Vout become not 0, Vout become a 10 volt. And here what is happening? That current is infinite. Why is infinite? If you are looking this path, there is no any resistance path here. There is no any resistance path. So capacitor will allow a sudden change. What is the voltage of that? So this is 10 there. It will not 0. It will be reaches to sudden 10. This is 10. This is 5. This voltage is 5 volt there. In a previous case, the bottom side is positive and the upper side is negative due to this 5 volt. Once this 10 volt is reaches and diode is short circuit, the upper one is 10 and bottom side is 5. That have a sudden change, that capacitor will hold the positive 5 volt from the upper side. And you can look at point from this is 10 volt, and if you are looking from this plus 5 volt, and plus 5 volt is 10 volt. You can check from this point or check from this point that Vout is remain 10 volt. So if you are looking for the waveform, if you are interested for the waveform, what is that waveform? So before T1 that V out is 0, because capacitor is act like a blocking circuit, that there is no current is passing through by the help of 5 volt. But after T1 just input is rising to 10 volt, the diode will be short circuit and V out become a 10. That have a sudden change there. That is very important point. The capacitor have a voltage of 5 and due to the diode is short circuit, there is no any charging time. It is charges suddenly, that the output is suddenly reaches to 10 volt, and V out is opposite the direction of charging and it is maintained plus 5 from the upper side. So that is the power of the diode. Diode just make that short. It is not like charging like this there. It is not taking a time, because there is a tau is 0, because there is no any path. There is no any path have a resistance. So that is the beauty of this question. So with the help of diode, we can limit that capacitor will charge fastly. It will not take time, but it will take time for discharge. So if you are focusing on the edge detection, okay, I am thinking in a way you have a question, okay, that I want a positive edge detection. There is no any so you just use this circuit and you find that okay, this is what will happen after this, I don't know, but after this it have a sudden change. It happen out at this point also. Whenever the input is rising to 10 volt, the output is suddenly changes to 10 volt. Whenever you have a rising edge there, this is a very important point. Whenever you have a rising edge, that output is suddenly to 10 volt. So that is the beauty of that question. What will happen on the discharging on the falling edge we will discuss, but whenever you have this circuit, so this is always maintained 10 volt. Why? Because as per the input is 10 volt, as per input is maintained 10 volt, as per diode is forward bias, the capacitor will have a 5 volt and this have a 5 volt, so V out is remain is 10 volt. So V out is that waveform is like this there. In a previous class we discussed that one RC circuit where that output is charging like this and discharging is like this and charging is like this and discharging is like this. So here that is the problem, that it will take a time, so the pulse width will be shifted, the delay is present here. But the help of the diode you can avoid the charging time, that it is charged suddenly. You just think in a way, okay, you have a waveform and you are using one like any circuit where you want that every positive edge, as per the positive edge, it will take the supply suddenly. But once that supply is off, it is discharging, but it will discharge slowly. So by the help of diode, you provide suddenly to the supply to the circuit. But once that supply will off, it will take time, because as per the supply will off, the input is supply is off, this diode will be reverse bias. The capacitor is discharging, but it will discharge by the help of R1, R2 and C. So this waveform is valid if input after T1 plus, if that input waveform is here, the after T1 to T2, it is remain 10 volt there. Why it is remain 10 volt? Because as per the input remain 10, this diode will be short circuit and V out is maintained 10 volt. So till T2 minus it is maintained 10 volt. I just use one component, that is diode only there, and everything is changed. You can detect positive edge. Similarly, you can detect negative edge if you are using that opposite direction of the diode. Okay, this will be an assignment for you, just focusing. I am just for focusing on the positive edge. For you, just check that at negative edge it will be sharply detect. This the circuit is detect positive edge. You can design for a negative edge. It is discharged suddenly and charging slowly. You can. Okay. After till T2 minus, this is 10 volt. The capacitor voltage is 5 and it is 5. So V out is 10 volt. What is happening after T2? So at T2 plus, the input voltage is suddenly 0. So input voltage is remains 0. You have a resistance. That is R1 and R2. And now you have a diode like this. And capacitor does not allow sudden change. So this is plus minus 5 volt and this is 5 volt here. So at T2 plus, the input voltage is sudden change, but that capacitor does not allow sudden change. Why capacitor is not changing here? In a previous case, capacitor is changing. Why not here? Because as per this is 10 volt here. On this is 0 volt. Due to this diode is behave like what? It is act like an open circuit. So capacitor will not suddenly discharge to this point, this path. It can charge suddenly, but it cannot discharge suddenly, because this is 10 volt, this is 0 volt, diode will be open, it is reverse bias. So capacitor will discharge by the help of R1 and R2 only. Yes, everyone, is it okay? So this is the waveform, and what will happen at t tending to infinite if this is remains same. If this is remains same, it is just like a t1 minus case. It is just like a t1 minus case. Okay, at if this is remain same after t2, it is remain tending to infinite, it is 0. So the input voltage remains 0. You have a resistor here and you have a resistance here, and this is open circuit, and this is 5, this is capacitor, and this is void. And I steady state the capacitor act like an open circuit. So I am designing in a way that you have a like this. So what will happen? This is become plus and this is become minus, and V out is what? It is just like a T1 minus case there. This is just like a T1 minus case. Just check it. This is T1 minus case, that the input is like this and diode will be open and it is like this. So what is V out? V out become a 10. V out become a 0 volt there. So when I steady state, it will be 0, but it will not 0 suddenly. It will take time. What will be the time? That is decided by the time constant. This is R1, this is R2. If you are looking from this capacitor, this R1, R2 are in parallel. So this is R1 parallel of R2 into C. This is tau there. So you can write your V out after T2 plus, that what is V out of T? That finally it will be 0. Initially it will be what? That initially it is 10 volt. Initially it will be a 10 volt. Finally it will be 0, and this is e to power t minus t2. After t2 it is happening upon tau, and where the tau is R1 parallel of R2 into C. So if you are focusing for the waveform, So capacitor it discharges like this, that V out will be towards that 0, and capacitor changes that from 5 volt to 0 and then 0 to -5, because this is changing that firstly it is maintaining 0 and then after it is 0, from this to it is become a bottom side positive. So you can think in a way it is discharging from 5 volt to -5 volt. Okay, so this is the question here you have. Okay, so if you have this waveform, you generally say that okay, this will be your output, this will be your output. It is discharging slowly, but it is charging fastly. And if you limit this pulse width, so it will not discharge till 0, it will take some less time. It will not discharge till 0. It will depends on the pulse width, how much time you are giving for that input is remain 0. Okay, by this equation you can find it. Because the charging or discharging depends on two things. The first thing is the tau, the time constant of the circuit, and second is how amount you are giving the pulse width for charging and discharging. So both are very important for capacitor charging and discharging. Okay, I solved one question. I want to give one question to you. Okay, you have this question there. This is an assignment for you. You have a D1 and you have a D2. Of course, that there is no any V gamma. So just think that V gamma is 0. That is the ideal diode. And these are the TI question. They are the ST based question. Okay, they are generally asked in a interview. Okay, you have a simple diode, and they will ask in a way, what is the V out waveform when the input is before T1 it is 0, after T1 become a 10 volt and it is remain 10 volt, and after T2 it will be 0. Okay, so just focus on it, what will happen. And I am using a 2 diode, so basically just check it, which one is forward bias, which one is reverse bias, which one is reverse bias, which one is forward bias. This is very important. If you will confuse here, so it will not give that correct answer. So just check, assume which one is diode is forward bias and which one is reverse bias, and then solve it. Okay, so for today only, that diode part is over. Just solve this question. We will start from this, or I am just making that waveform. And firstly, design this circuit, analyze this circuit, check your waveform on simulation side. Okay, and you find it. Okay, so this is the part, and I hope so. In the next class we will start simulation on the diode based question, and maybe with the cadence, or maybe with that LT spice, it depends. Okay, and if that I am starting with a cadence, so I will go for that from basic question from RC, and then we'll go for the diode. Okay, and then we go for the switching. Okay, switch based question, that is very important when you have a different switches, how that capacitor is charging or discharging with the charge conservation funda. So we will start after 1 or 2 class, and then I will cover that RC. Okay, so RC is very vast, but I will not give some everything to you at that point. Just start at your end firstly analyze this circuit, then we can proceed properly. Okay, so thank you so much for this, and we will meet on next class. Thank you dear.